Yeah, this is a great question. A polygon is said to be friendly if it's regular and also has angles that, when measured in degrees, are either integers or half integers. So these interior angles here. Now, it's actually quite tricky dealing with interior angles because you have to do the number of sides minus 2 times 180 divided by the number of sides to see if you get a whole number or a half integer. Much better to look at the exterior angles, these ones here, because if the interior angles are integers or half integers, the exterior angles must also be. I'm just going to write that down. Okay, and therefore we require, remember, to get the sum of exterior angles is always 360. So we require 360 divided by n to be an integer or half integer. Look, I'm showing more explanation here than you'd need to in the real thing, but I'm just trying to make it clear. So obviously I'm taking a bit longer. Now, if it's a half integer, then I can times by 2 and get 720 over n, which then just needs to be an integer. Because if I got 0.5 here, if I times by 2, I'd get 1. So I can just focus on integer solutions, which is much easier to deal with. Okay, so that's a little thing you have to realize in this question. Okay, and now we just need to work out how many factors 720 has. And this can be done using, you don't want to be listing them all really. That's going to take some time. There's a nice little way you can do it with prime factorization. So I'm gonna follow that process. Okay, till I get my prime factors 2 and 5, 18 and 4, 2 and 2, and then this is going to be 9 and 2, 3 and 3. So 720 is 2 to the power 4 times 3 squared times 5. Now, to get the number of factors, what you can do is you can take the indices and add 1 to them and then times those numbers together. So number of factors, this is well worth knowing, is going to be 5 times 3 times 2. I've just added 1 to each of them respectively, times them together, which gives me 30 factors. Now, I want to just talk a little bit about where that's come from, because maybe you've never seen it before. I'm going to take a more simple example. So let me take 3 squared times 2 cubed, which is actually 9 times 8, 72. Yeah, okay. Now I could write these are this is the prime factorization. Now I can consider all the factors of this number like so. The basic factors would be 3 to the 0, that's just 1, 3 to the 1, and 3 squared. And then 2 to the 0, 2 to the 1, 2 squared, and 2 to the 3. But I can get other factors. Now I'm going to think about the way they can link together. So 3 to the 0, I can link to 2 to the 0 to give me a factor of 1. And then here I can get a factor of 2, here 4, and here 8. So I can link those together, and I can do similar for the other ones. Now I can get a factor of 3, now of 6, now of 12. And using this idea, I'm going to guarantee that I get every single factor because I'm just pairing up all the different powers that go into this prime factorization. So I must have them all at the end. And I just need to work out how many links there are. And it's just going to be 3 times 4, which is 12. And all I've done is added 1 to the power, added 1 to the power, times them together. The plus 1 comes from the fact that you have to consider the power 0 in there. So I don't know. That was a quick explanation, but read up on it more if you're not happy with that. So in this case, we have 30 factors. So are there 30 friendly polygons? Well, actually, I made the mistake of saying yes, there are, but there's not because we have to reject two of them. Reject n equals 1. We can't have a polygon with just one side, even though it fulfills this problem. It's just not a physical solution. And n equals 2, because you can't have a polygon with two sides. But all the rest are okay, and therefore the final answer is 0 to 8. Good question.